Okay, so this video is just to give a little guidance, a couple examples of the honors homework. And so it's linear programming, but these word problems where you have to identify what the variables are, figure out what the objective function is. So in this case, it would be like to maximize profit. Well, what does the profit look like? Then you're going to graph some constraints, find the vertices, and find the solution. So pretty extensive problems, and it says you only have to choose 3 of the 5 that are on that page. Example number 1. Small company makes custom messenger bags and backpacks, sells them through a vendor. Company can make no more than a total of 80 bags and backpacks in one day. Okay, so I'm going to identify some variables. M is the number of messenger bags. And B would be the number of backpacks. All right, and so what do we know? So our constraints. Company can make no more than 80 bags, so M plus B has to be less than or equal to 80. The vendor promises that it can sell at least 10 and no more than 50 messenger bags per day. So the number of messenger bags has to be less than or equal to 50, but should be greater than or equal to 10. Backpacks must be at least 25, so the number of backpacks greater than or equal to 25. Company makes a profit of, okay, so here is the objective information. We're making profits. Company makes a profit of $12 on each messenger bag and $8 on each backpack. That is the objective function. Profit is equal to $12 times M plus $8 times B. 12M plus 8B. How many messenger bags and backpacks should they make each day? Okay, so here is our graph, and usually we have something like time on the x-axis, but this time the only 2 variables we have involved are M and B. So I'm going to put messenger bags over here, backpacks over here. Since we're going up around 80, I'm going to go every 2 blocks is going to be 10. 70, 80, 90, 100. Okay. That would be backpacks, and then messenger bags, 0, 10, 20, 30 is right there, 40, 50, okay, so now it's time to graph our constraints. We know that messenger bags has to be between 10 and 50. We know that the backpacks have to be greater than or equal to 25. So there's the 25 point. And at the moment, we are looking at this area in here. All right, and then the last one that we need to deal with is this M plus B is less than or equal to 80. Okay, which one of these is on the y-axis? It's M. So I'm going to solve for M. Oops. And get M is less than or equal to negative B plus 80. So I'm going to start at 80, and then I will go down 1 over 1. So if I go down 10, I would need to go over 10. Down 10 over 10, down 10 over 10. Okay, so that line would be right there. All right, and we have graphed all the constraints, so now we just need to find all those vertices. There's one there, one there, one there, one there. And our goal here is to maximize profits. So we're going to list all the vertices. We've got 25, 10. And just remember that the first number is the number of backpacks, the second number is the number of messenger bags. Another option would be 25, 50. Another option would be 30 and 50. And another option would be 80 and 10. Okay, so one thing that I know is if I'm trying to maximize profit, so for example, the first one and the second and the third one, both of those sell 50 messenger bags. One sells more backpacks than the other. So the one who sells only 75 can't be my choice. Another one, 25 and 10, can't be my choice because 80 and 10 is going to make me way more money than selling 25 and 10. Okay, so I'm going to only plug in the last two because those are the only two that I see as being viable options. All right, so profit we know is $12 times M plus 8 times B. So 12 times M plus 8 times B. And so this case would be 600 plus 240. Looks like $840 for this one. And for the other one, 12 times 10 plus 8 times 80. 120 plus 640, 760. So 30 backpacks and 50 messenger bags. That's my solution. Okay, in a second example, this one get a little more complex. It says that a plant makes aluminum and copper wire. And each pound of aluminum wire requires 5 kilowatt hours of electricity and 1/2 hour of labor. Each pound of copper requires 2 kilowatt hours of electricity and 1/2 hour of labor. Production of copper wire is restricted by the fact that raw materials are available to produce at most 60 pounds per day. Electricity is limited to 500 kilowatt hours per day and labor to 40 person hours per day. If the profit of aluminum wire is 0.25 pounds and the profit of copper is $0.4 per pound, how much of each should maximize profit and what is the maximum profit? Okay, I'll start with the objective profit, the objective function, which is for profit, which is 0.25 times aluminum Okay, sorry, I had to pause. So let's go. I put profit up here, so 25 cents per pound of aluminum, 40 cents per pound of copper. And so A and C are my variables. A is pounds of aluminum wire, and C is pounds of copper wire. All right, and then started reading through this, and there's a lot to decipher here. So it talks about each pound of aluminum. So this is with A, requires 5 kilowatt hours of electricity and 1/4 hour of labor. Okay. So we need to go down here. Oh, and copper also requires 2 kilowatt hours and 1/2 hour of labor. If you go down here, you kind of see where here are our constraints. Electricity is limited to 500 kilowatt hours per day. Okay, electricity has to be less than 500. Okay, well, how is the electricity spent? Well, a pound of aluminum requires 5 kilowatt hours. That's from there. So 5 times however many pounds of aluminum plus 2 kilowatt hours times however many pounds of copper wire we make has to be less than or equal to 500. Okay, so we have dealt with this constraint here. They also give us this. Copper wire is restricted in that you can only produce 60 pounds per day. So that's copper has to be less than or equal to 60. And the last one here has to do with the labor, 40 person hours per day. It says that it takes 1/4 of an hour labor for aluminum. So I did 0.25 times aluminum plus 0.5 times copper has to be less than or equal to 40 hours per day. So these are our 3 constraints. Here's our objective function. Now we need to graph on this. We'll do, let me see if I can move this over a little bit. All right, and you just kind of pick which one you want to go where. I'm going to do copper up here and aluminum down here. This is pounds of aluminum wire. This is pounds of copper wire. Start here, and let's see. This will be less than 60, so I'm going to do by tens like I did on the last one. I may regret this. 40, 50, 60. Okay, and I'm going to stop there for copper because it tells me copper's got to be less than 60, less than or equal to 60. And on the y-axis, 0, 10, 20, 30, 40, 50, 60, 70. Okay, so I've taken that one already. Now I have to solve both of these for C, because C is on my y-axis. So if I want to graph those, got to solve them both for C. I'll drag this one over here. 2C less than or equal to negative 5A plus 500. Oh dear, I see a problem. C has to be less than or equal to negative 2.5A plus 250. You know I was going to regret it. Okay, so you can maybe alter your numbers here. 90, 100. But I know that negative 2.5 times 100 is negative 250, which would mean if I had 100 pounds of aluminum, I would have 0 pounds of copper. So I know that I have a point right there. Okay. And if I did 50 pounds of aluminum, that would be 125. So that would make this 125 for copper. So when aluminum is 50, copper is way up there. I don't want that yet. I want to know what happens when copper is 60. I'm just trying to find my vertices. Okay. So if I do 60 minus 250, and this is just me being a little on the lazy side. And I got A is 76. 76, 60. Okay, and basically what I'm doing is I'm finding the intersection of this line and this line, okay, because that's going to be one of my vertices, right? And when do those things intersect? They intersect when they equal each other, which is what this line right here says. Whoops. Okay, so I'm going to draw that line. And this point is 100. 0. Okay, so that was a little lazy. I apologize. Nah, not yet. And then this one over here, I'm going to solve again. I have to solve for C. So 0.5C is is less than or equal to negative 0.25a plus 40 divided by 0.5. Get C is less than or equal to, so a fourth divided by a half is equal to negative 1/2 a plus 80. 70, 80 is right here. I could do the same thing to find when this line will intersect this, so I could set this equal to 60 and solve. Negative 20, negative 2 is 40. So when A is 40 here. So what I also could do is I go down 1 over 2, which is the same as going down 10 over 20, down 10 over 20. I'll get to that point as well. Ooh, it's going to be tough to find that intersection. It looks like it's right here in that point. So this point is 40, 60. This one's so much more exciting, y'all. 70, 85, 40. And I'm going to check that point again in just a second. Okay, and then we also have another boundary right here. Okay, so if this is my shaded region, I'm also bound right here. Okay. I'm bound to this area, because I have to be below the black line, inside the red line, and then above, I have to have positive pounds of copper. I'm not going to do negative. So I've got 0, 60 here, and I'm going to erase this one, okay, because that point is outside the shaded region. So I've got 1, 2, 3, 4 points to check. And at the end of the video, I'm going to make sure that that 8540 is correct, but if you don't want to see it, then I won't make you see it. I'm going to check all these points. I bet 0 and 60 isn't going to be a way to maximize profit because I have 40 and 60. That sounds like a better option. I have 85 and 40, and I have 100 and 0. Okay, so now we're going to plug those into the profit equation. So profit is equal to, and remember my first column is pounds of aluminum, then this is pounds of copper. I'll do the bottom one first. 100 times, why did I do it? Oh, pounds of aluminum times 0.25 plus 0. So this would be a profit of $25. Wow, that is just not a great amount. The next one, we've got 85 times 0.25 plus copper, 4 times 4. That's $16. This is $21.25. And this is $37.25. 40 and 60. I'm going to get real crazy and do it like this. 0.25 times 40 plus 0.4 times 60. So that's 24. That is 10. So that's 34. Boom. Maximum profit is $37.25, and that happens when we do 85 pounds of aluminum and 40 pounds of copper. Bonus footage. I want to make sure that this line intersects this line at 8540. Negative 2.5a plus 250. And is that equal to 1/2, negative 1/2a plus 80. C is equal to negative. Ruh-roh, copper is 37.5. Real thing? Yep, I believe it. If you're still watching, that should be a 37.5, but I still think it's the most. 2.5 times 0.4. That's only $1 difference. $36.25. Alright, sun's setting. I'm done. Enjoy the rest of the honors assignment, and if you have questions, just shoot me an email.